Welcome to the Explainer. If you're wrestling with distributed systems, you've come to the right place. Today, we're going to break down task assignment and turn this critical concept into your secret weapon for any exam.
Okay, let's just jump right in. Picture this. You're basically a project manager, right? But your team, it's not people. It's a whole network of seriously powerful computers. And you've got this massive pile of jobs to do, and they all need to be done like yesterday. So the million-dollar question is always, who does what? How do you figure out which task goes to which computer? You got to make it fast, you got to keep it cheap, and you absolutely cannot let one computer get buried in work while the others are just chilling. That puzzle, that's the heart and soul of task assignment.
So here's our game plan for today. We're going to start with the absolute must-know definition. Then we'll get into the three main goals you're always aiming for. After that, we'll look at the big strategic choices, static versus dynamic, and push versus pull. And to wrap it all up, we've got an exam recall kit that's going to make sure all of this is locked in tight.
First things first, let's lay down the law. Before we even talk strategy or anything fancy, we need to be 100% clear on what task assignment actually is, and maybe more importantly, what it isn't.
Okay, so this is the golden rule, the most important part. In task assignment, you take a complete task, the whole thing, and you hand it off to one specific processor. That's it. You don't chop it up, you don't split it into pieces. Once it's assigned, that processor owns it from start to finish. It's really the one job, one worker rule for distributed systems.
And here's that rule broken down into three super simple steps. Step 1, you assign the task. Step 2, it goes to one processor and only one. And step 3, that processor runs it all the way through, completely. That's the whole life cycle. Nice and simple.
All right, so we know the what. Now let's talk about the why. Why are we doing all of this? Well, it all boils down to hitting three main objectives. You can think of these as the three giant pillars that hold up the performance of your entire system. A good task assignment strategy is really just a constant juggling act between these three things. First, you want to get the job done as fast as possible. Minimize that total execution time. Second, you got to cut down on the network chatter. That's your communication cost. And third, you have to balance the workload, right? You can't have one machine doing all the heavy lifting while the others are on a coffee break. If you can nail all three, your system's going to fly. And this quote just hits the nail on the head. It's so tempting to just look at how fast a processor is. But in a distributed system, your computers might be far apart. And the time it takes just to send the data back and forth, that communication cost, can be a massive bottleneck. Sometimes, sending a big job to a super fast processor that's far away is actually slower than sending it to a closer, slightly weaker one. It's a huge deal. Okay, now for our first big strategic decision. And it's all about timing. Do we figure everything out ahead of time, before the work even starts? Or do we make decisions on the fly, adapting as we go? This is the fundamental difference between static and dynamic assignment. All right, so here's where we see the classics trade-off. On one hand, you've got static assignment. Think of this as the super organized pre-planner. Every single decision is made before anything starts running. It's perfect for stuff you can predict, like a big database job that runs at 2 a.m. every night. The big win here? It's simple, it's clean, there's almost no overhead. But the catch? It's rigid, it's totally inflexible. If something unexpected happens and the workload changes, well, it's stuck. On the flip side, you have dynamic assignment. This one is all about thinking on its feet. It makes decisions in real time as things are happening. This is an absolute must-have for unpredictable work, like handling live requests on a super busy website. It's amazing for balancing the load on the fly, but that power comes with a cost. It's way more complex and creates a lot more chatter between your machines. Now for our next strategic choice, this one's about who's in charge. Who actually initiates the work? Does a task go looking for a free computer, or does a free computer go looking for a task to do? That's what brings us to the push versus pull models.
This analogy just makes it all click, doesn't it? The push model is all about the task. You can think of the system like a manager who pushes a job onto an employee. Here, you do this. The pull model is the other way around. It's centered on the processor. This is like an employee who finishes their work, walks up to the manager and says, "I'm free, give me the next job." They pull a task from the list. And you can see how these tie into our last decision, right? A dynamic system might love the pull model, where idle processors just grab work when they're ready. A static system often uses a push model, where everything is assigned up front. So you get the ideas. You see how it all fits together. But there's a big difference between understanding something now and remembering it perfectly when you're staring at an exam paper. So let's get to our last section, the exam recall kit, designed to just sear this stuff into your memory.
Here you go. If you get a question that says define task assignment, this is your perfect answer. This will get you all the marks. It hits every keyword. It's a scheduling technique. Tasks go to a specific processor. They're not divided. And the whole point is to optimize performance by cutting costs and balancing the load. Seriously, just memorize this sentence.
Now, to remember all the different pieces, just use this code 1MCL-SD-PP. It's like a mental cheat sheet. 1 reminds you of the main rule, one processor, not divided entire task. MCL gives you the goals, minimize time, communication low, load balance. SD are the 2 types, static and dynamic. And PP are the 2 models, push and pull. That little acronym has the entire topic packed inside it.
And if you want something even quicker, just for a last-minute brain check before you walk into the exam, repeat this to yourself. 1 task, MCL goal, static dynamic, push-pull. That's the whole framework in 5 seconds.
And look, for anyone who learns a little differently, who needs something a bit more epic, let's try the anime power-up version. Seriously, the code is 1 MCL SD PP activate. Just think of it as powering up for your exam. Step 1 is your base form, 1 mode, simple, solid. Then you power up to form 2, activating the MCL aura. That's your efficiency boost. Next, you hit form 3 with the SD shift. You're controlling time now. And for the final move, you unleash the PP command. I know, it sounds a little out there, but you'd be surprised how well this kind of thing can stick in your memory when you're under pressure.
So let's wrap this explainer up with a final thought. Right now, figuring out the best assignment strategy takes a lot of human insight. There's a real art to it. But as our systems get smarter with AI and machine learning, do you think that art will eventually become a fully automated science? Will the system just figure it all out for itself? That's a really interesting question to chew on as this field keeps getting more and more advanced.